Hello, everyone. My name is Tausif Bordoloi. I am a final year PhD researcher at the University of Manchester. Today, I will be presenting our research in progress paper titled Systematic Characterization and Operationalization of Cyber-Physical Convergence in the Context of Industry 4.0. In recent years, the concept Industry 4.0 has become pervasive in academic, private, and public policy circles. It is used to describe technological and organizational trends related to the modernization of industrial production systems. It was, however, initially coined in Germany to form the basis of Germany's National Industrial Strategy 2030. It represents a bid to maintain Germany's industrial leadership at a national, European, and global level. So what exactly is Industry 4.0 about in technological terms? According to policymakers, Industry 4.0 represents the interlinking of machines and the internet. Or in other words, it is a convergence of the cyber and the physical worlds. One of the key remits of Industry 4.0 policy is to fund knowledge production related to cyber-physical convergence. In this context, appropriately defining the research domain and then measuring its academic output is a critical step in setting the right policy course for the future. Yet, little or no effort has been made to systematically characterize the notion of cyber-physical convergence, and attempts to operationalize the convergence research domain have been ad hoc and imprecise, meaning this represents both conceptual gaps as well as boundary gaps. In this paper, our contributions are twofold. First one is definitional, wherein we characterize the notion of cyber-physical convergence as described by the original proponents of Industry 4.0. And secondly, methodological, where we operationalize this definition by developing a control lexicon of keywords using text mining approaches. First, I will discuss the definitional aspects. To define cyber-physical convergence, we drew on a set of foundational Industry 4.0 policy literature that were published by Acatech, which is the German National Academy of Science and Engineering. The first report came out in 2011, and it is a position paper on cyber-physical systems. The second report came out in 2013, and it sets the cyber-physical convergence agenda in the context of German manufacturing. The third one is about promoting an integrated research agenda for cyber-physical convergence. Now, using this approach, we closely aligned the definition of convergence as guided by policymakers. Now, according to this definition, cyber-physical convergence involves a set of data-centric functions, meaning data lies at the heart of any convergence system. According to this definition, cyber-physical convergence starts with the ability to capture data or sense data from manufacturing or production systems via sensors. And once this data is collected, it is then subjected to different processing steps whereby information, the data is converted into information to interpret the situations in different terms. For example, it can be used to say diagnose a technical problem or for performing predictive maintenance. These data-centric functions would help reduce the response time between detecting and addressing a problem. So basically, these data-centric functions are combined to derive actionable insights, which are then used for decision making on the shop floor. What this means is advanced technologies, for example, additive manufacturing, will not necessarily convey convergence unless the data that they produce is effectively harnessed and analyzed. Conversely, legacy machines can be convergent if they interact sufficiently and effectively with the cyberspace. This definition is helpful because it helps separate out random attributes that are often associated with Industry 4.0. And secondly, it systematically delineates the technological research domain that policymakers seek to fund and support. Now, once defined, the next step involved operationalizing this domain, this definition. To do that, we had to address even more fundamental question, which is the question of how exactly do researchers working in the domain use the term data in their publications. Addressing this question is important because it involves translating the data-centric functions into a controlled lexicon of keywords. To operationalize this definition, we adopted a methodology proposed by Mogotov and Kahan in 2007. In this methodology, there are a series of steps involving searching for relevant publications and then subjecting them to text mining. The methodology starts with a simple query, which is used to search for relevant publications in Scopus. These publications are then subjected to text mining approaches to derive mid to high frequency keywords. Now, high frequency keywords from publications is effective for operationalizing emerging technological domains. And mid frequency keywords play a complementary role in this process. So combining these mid to high frequency keywords, we produced a query 2, which is then used to search for relevant documents. And then the process of text mining is repeated to enrich the relevant mid to high frequency keywords. Overall, these keywords represented and operationalized the cyber physical convergence research domain. This slide discusses the modular lexicon building methodology in greater detail. The first step, as I mentioned, it involved selecting benchmark publications in English and German from 2010 to 2019 using the following query. The publications were cleaned, and the final clean data set contained 96 publications. The second step involved identifying relevant keywords from the title, abstract, and keywords of those 96 publications by applying text mining tools, QDA Miner and WordStat. The relevant keywords were extracted and each associated with a specific data-centric capability. And I'll come to that in the next slide. These keywords were extracted based on their frequencies and TDF-IDF scores. A TDF-IDF score stands for term frequency, inverse document frequency. It is a score which combines both keyword popularity and discrimination to evaluate how important a term is to a publication in a corpus. We selected terms of frequencies equal to or greater than 30 and TDF-IDF scores of greater than or equal to 24. Some of these keywords were combined to form query 2, which is shown here, which formed a robust search space from which papers that were just to embody convergence were extracted. Finally, the query 2 was used in another round of searching, which are again subjected to text mining approaches as before. A total of 16 keywords equal to 5 data-centric capabilities were extracted. And these keywords collectively operationalized the cyber physical convergence research domain. This slide shows the keywords extracted using query 1. There are 5 data-centric capabilities: monitoring, analytics, modeling, transmission, and security. And there were 8 relevant keywords: monitoring, sensing, analytics, modeling, transmission, network communication, and security. As discussed, each of these keywords has a total frequency of equal to or greater than 30 and a TDF-IDF score of equal to or greater than 24. The enriched lexicon using both query 1 and query 2 is shown in this slide. There are 5 data-centric capabilities: monitoring, which means the collection of data from manufacturing and industrial processes. And the keywords included are monitoring, sensing, acquisition, and collection, as in data acquisition and data collection. Analytics means the analysis of the collected data to extract useful information. And the keywords included are analytics, learning, neural network, and intelligence. Modeling involves the virtual modeling of states, conditions, and behaviors of systems. The keywords are modeling and simulation. Transmission is a transmission of data across different hardware and software systems. The keywords are transmission, network, communication, and wireless. And finally, we have security, which represents cybersecurity to safeguard critical industrial assets. The keywords are security and attack. So a total of 16 keywords represented the cyber-physical convergence research domain, each associated with 5 data-centric capabilities. Summing up, this research presents a text mining approach that builds on the technological underpinnings of Industry 4.0 to define cyber-physical convergence. This definition is then operationalized using a modular query building process that allows us to characterize convergence into 5 data-centric capabilities. The limitations of this approach arises from differences regarding what other experts might consider important as to the definition of cyber-physical convergence. This may affect the choice of keywords identified. Now, this research forms part of a broader doctoral research to investigate policy interactions with academic research. In the future, we will apply these keywords to perform bibliometric search of the cyber-physical convergence research domain. Thank you so much for your time and attention. This is a bit about myself again. I'm a final year PhD researcher, and my doctoral research centers on 2 areas. One is policy and research interactions in manufacturing and adoption of digital manufacturing technologies. If you are interested to know more about my research, please email me at tausif.bordoloi@manchester.ac.uk. Thank you once again for your time and attention.